moving forward, we get to one of the most complicated theories that physics has brought to date, that's quantum mechanics. And yeah, probably you have bad memories from high school doing quantum mechanics and calculating, I don't know, quantum numbers, energy levels. Yeah, so you're not the only one. Even experts in the field face the same difficulties. I mean, not exactly the same, but kind of similar. So the pioneers, you have this guy in the middle that's staring at me. That is Max Planck. He's really, I think, considered as the father of quantum mechanics. And essentially, I mean, on the left you have Erwin Schrödinger, and on the right you have Niels Bohr. So essentially, what Planck did at the time was showing that electromagnetic radiation actually propagates in a discontinuous fashion. And he proposed the idea of the quantum. In other words, if you have light, I mean, the light that you see everywhere, it can be sunlight, it can be any electromagnetic radiation, that propagation is not continuous. It actually takes place in minute lumps, okay, of energy that we call quanta. And every lump is a photon that carries a definite energy. So that was a revolution in the 20th century, and there's really a whole group of scientists that contributed, physicists in particular, that contributed to make this understanding possible, and yet there still remains a lot of unanswered questions. But yeah, that was really a revolution, and it enabled us to really probe more into the atomic scale and understand what happens inside atoms. So here we are clearly in the microscopic region of the world. Now, what can we do with this? We can build interesting electronic devices. We can build transistors, we can fabricate lasers, and so on. We can do medical imaging as well. So yeah, there are a lot of electronic components. You may probably know of resistors, capacitors, inductors, and so on. But the key electronic component that really kind of revolutionized, let's say, the way we live and revolutionized even technology is the transistor. Because from the transistor, we can do a lot of interesting things. So just to say a few words about the transistor is just a device that you can use to connect two circuits together, but you can also use it to amplify, which means you give it a certain amount of current at the input, and at the output, you have it being scaled. So that has really been a revolution. And you know that when we when we are involved in transmitting signals, there are usually losses that we have to incur. And if you have a device that enables you to scale like the tiny signal you're having, then that's really groundbreaking. So that has been a very important application of quantum mechanics, but there are many other ones as well.